Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on an introduction to hypothesis testing. I wish to thank Mrs. Borlaug for allowing me to use her PowerPoint to make this set of videos. What is hypothesis testing, and why do we do it in statistics? By definition, the hypothesis is a tentative assumption made in order to draw out and test its logical or empirical consequences. Hypothesis testing is a scientific way of testing theories and discovering facts that can be proven and assumptions that need more study. Mathematics and statistics is at the heart of such studies. First, you make a tentative assumption. It will rain tomorrow. Then, if that is our assumption, we have to think about what the opposite of that assumption is. If our assumption is it will rain tomorrow, the opposite of that will be that it will not rain tomorrow. So our two options are it will rain tomorrow or it will not rain tomorrow. It will rain tomorrow is called our null hypothesis, and we indicate this with H and then a little sub 0 or O as its notation. Two dots and then its statement. This is the null hypothesis. H1 or HA, depending on your textbook, is it will not rain tomorrow. It is the opposite statement, and it is called the alternate hypothesis. Notice how the null and alternate hypothesis are opposite statements. Now, once we've made our assumption and our statement, we have some things that can happen, and we're going to make a chart of those things. For now, don't get too caught up in the labeling of those. Those kind of come as we fill in the parts. Let's first look at what our decision would be. We've made an assumption. It will rain tomorrow. One of two things can happen. It will either rain tomorrow or it will not rain tomorrow. Two things can happen with the weather once we've made our assumption. And two things can happen in our reaction to the weather. We can either believe the statement that it will rain tomorrow, or we can reject the statement that it will rain tomorrow. If we reject the statement that it will rain tomorrow, then we leave our raincoat and our umbrella at home. That's rejecting the assumption. If we believe the assumption, then we take our umbrella with us and we're prepared for rain tomorrow. So now kind of look at what we have. We have that the assumption is true, that the null is true, that HO is true. If HO is true, that means it's raining. If HO is false, it means it's not raining. In our case, that's represented with the sunshine. We can either reject the null or the HO by leaving our raincoat and our umbrella at home, or we can accept the null and take our raincoat and umbrella with us. So what happens if we reject the null? If we reject and say our assumption, if we say the assumption is if we reject it and say we don't believe it, it will either rain or it won't rain. So if we reject and think that the null is false, if we think the statement it will rain tomorrow is false, and yet it does rain tomorrow, this creates what is called a type one error. Because we're wrong. We believe the statement was false, but it is true. So we're standing at the bus stop in the rain getting wet. This is the alpha risk. This is what we call a type 1 error, and we will call the risk of this the alpha risk. If we assume the statement is false, and it indeed is false, and it does not rain, then we've made a correct decision. The sun is shining, we left the umbrella at home, and we can build castles in the sand. Now, the other option is for us to accept that it will rain tomorrow. If we accept that it rains tomorrow, and it does indeed rain tomorrow, we've got that umbrella, we're carrying our umbrella in the rain, and we remain dry. So if we can remain dry by accepting the statement and it raining, or we can remain dry if we reject it and the statement is false. Those are the two options for correct decisions. A type 2 error will occur if we accept the statement, but the statement is false. A type 2 error means we're carrying an umbrella, but there is no rain. And this is called the beta risk. For our introduction class, we look at minimizing and controlling the alpha risk, and we will not define the beta risk. Think about it this way. Would you rather carry an unnecessary umbrella or be getting soaking wet standing out in the rain? So we're more interested in reducing the risk of getting soaking wet. So we're reducing the type 1 error, and we do not look at in our method in this introductory class at the beta risk. So in the procedure, we will learn the beta risk will never be defined. So our type 2 beta risk is undefined. So never say that you accept the null hypothesis. Because of the way that we've set these up in our class, never say that you accept the null hypothesis. Never accept the null hypothesis. Never say, I 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 accept the null hypothesis. Now, what did I just say? Never say what? Never say, I accept the null hypothesis. Why? Because the beta risk will not be defined. In statistics, you only want to say things that you are sure have a low risk of being wrong. In the procedure, we will learn the alpha risk will be defined, and it will be very small. The alpha risk is defined and very small. What may you say with only a small risk of being wrong? Well, since that is on the reject, so based on the data, you may either say, I reject the null, or you do not reject the null. So the only two statements that we will say in our introductory class to statistics in hypothesis testing is you reject the null or you do not reject the null. because we're only looking at the type 1 alpha risk. Rejecting the null hypothesis is the same as accepting the alternate hypothesis H1. Since H1 is what HO isn't.